Continuing with the chemical properties of alcohols and phenols, we have seen some reaction wherein we go to study the acidic nature of alcohols as well as that of phenols. In this particular subtopic, we are now going to compare the acidity of alcohol with that of phenol. Let us first take up with the acidic character of alcohol. Now, when it comes to alcohol here, the acidic character depends upon the polarity of the OH bond, because when we say that it is showing a acidic character, it is the ease at which the hydrogen ion is given out. So, here what we find is that this is a very simple example wherein we find a methyl group is carrying a hydroxy group. Here oxygen is bearing a partial negative charge and hydrogen is bearing a partial positive charge. Now, here what we find is that as we go on substituting each of a hydrogen by a alkyl group, we obtain a primary, a secondary and that of a tertiary alcohol. But when we go to study the nature of this alkyl group, know that the alkyl groups are electron donating group. So, as the number of electron donating groups go on increasing, it so happens that the electron density is concentrated over here on this particular carbon atom, which is carrying the hydroxy group. Now, this disturbs the polarity of OH bond. When I say disturbs, it goes to decrease the polarity between the OH bond. So, as the number of alkyl groups go on increasing, the electron donating nature, because of this, the concentration of a negative charge takes place on the carbon, polarity is decreased and hence the acidic character also decreases. So, here as we move on from primary to tertiary alcohol, acidic nature of alcohol is found to decrease. Continuing with this, we also find that when we go to react alcohol with that of water, it's found that water is become a better proton donor, because when we say that it is showing a good acidic character, it should donate proton, it's give out hydrogen ion. But when we compare the two, it's been found that water is a better proton donor and thus alcohol act as Bronsted base. Now, this nature of alcohol is because of the unshared pair of electrons which is present on oxygen. In general, when we talk about the acidic nature of alcohol, we write it as alcohol goes to form alkoxide ion with the liberation of hydrogen ion. Now, as we have said, we need to compare the acidic character with that of phenol. So, let us study how phenol goes to show the acidic character. First of all, understand that the phenols here, the OH group which is attached on the benzene, that is OH group, is attached to a sp2 hybridized carbon atom. This attachment of a hydroxy group on a sp2 hybridized carbon atom over here, it shows that this hydroxy group over here is acting as an electron withdrawing group. Now, when I say electron withdrawing group over here, when I go to show the resonance, this goes to share the electrons over here and you find the movement of electron taking place in this manner. So, if you go to see, the negative charge is coming over here at the ortho and that of para position. So, till all the 5 resonating structures that we see, we find a negative charge coming at the ortho and para position, and in this 3 resonating structure a positive charge is being carried by a oxygen. Now this resonance causes the oxygen of the hydroxy group carry a positive charge. When we see phenol undergoing or showing a acidic nature, it goes to form a phenoxide ion along with a hydrogen ion. So this is the hydrogen ion which is given out because of its acidic character. Let us talk about how stable will be this phenoxide ion. When we talk about the stability of this phenoxide ion, we need to observe its resonating structures. These are the resonating structures which are being seen in the case of phenoxide ion. If you see, it's almost similar to what we have earlier, but what we find here in this case is again the negative charge is coming to the ortho and the para position, and there is no charge which is being carried out in the 3 resonating structure over here in the oxygen. These number of the resonating structure does show a stability for a phenoxide ion. So delocalization of this negative charge rather stabilizes the phenoxide ion, and hence I can say the reaction over here is more favored on a right hand side, that is on the product side, formation of a phenoxide ion. Thus, I can conclude that phenols are found to be more acidic in nature than that of alcohols, because if you go to see in the case of alcohols, you find that here it goes to just form an alkoxide ion. So negative charge is being just balanced or taken care of by the alkyl group which is attached to it. Whereas in the case of phenol, it goes to form 5 resonating structures over here which goes to stabilize this negative charge. Hence overall, when we go to compare the acidic nature of that of alcohols and that of phenols, we find phenols are more acidic in nature as compared to that of alcohols.